Hey, everybody, this is Larry. This is day 15. Wow, middle of the month already of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I actually, today I actually record before I decide what video intro to do. Still in Aruba, so hopefully you enjoyed it. If not, let me know. If you do, let me know as well. But yeah, it is my last day though. So tomorrow you'll see me back in sunny New York. Yeah, wow. Anyway, today's poem is 1048, longest string chain. Okay, so given words where each word is a lowercase letter, okay. You're trying to get insert one character, okay. Uh, without changing the order. Okay, so then now we're trying to get the longest character, right? Um, yeah, huh. This is the longest path in a DAG, which is dynamic programming, which I guess now that I think about it and have forgotten, to be honest, it is the theme of this week. So the idea here is basically, I mean, we've been saying this a few times this week, right? So we have this is longest path in a DAG, and basically we just do memorization, right? Of course, you can do it bottoms up as well, but yeah. Let's see, a thousand times. I guess it's 1,000. Choose two, so it's like 8 million. Still feels a little bit a lot, but we'll see how that goes. Yeah. So I actually, but today I'm going to try to do it bottoms up, and the way that I look at it is, best. So let's say n is equal to length of words. I'm gonna this today. I'm gonna try something new because all week we're doing dynamic programming. So I feel like I've been repeating some stuff, right? And and if this is your first video of the week or whatever, check out the ones from the last couple of days, and hopefully, that would make sense. But today I'm going to try to do it bottoms up because I think I do want to spice things up a little bit. Um, yeah, and then the idea here is that the way that I think about it is that okay, what is I, right? So here for I, what we want is for I, or for words of I, what is the longest chain that ends here, right? So that's basically the idea. And then the longest chain that ends here is one plus the longest chain that connects to here previously, right? And of course, we said this before, which is that this is a DAG because you can only insert, right? So given all these words, you can't go backwards. There's nothing like that. You have to go to the left, right? Or you go going from left to right or something like that, and it'll be a DAG. I think one thing that I kind of messed up here, or not messed up yet because I haven't submitted anything, is that we should sort, right? So that we get that ordering from left to right. It'll make our code easier. Is technically not necessary, but it just makes our code easier. Otherwise, you have to check all the other ones, and even though there'll be an implicit DAG, this one will be a little bit faster as well because after the sorting, you can do n choose two instead of n square full, right? And that's just literally 2 times faster minus the cost of sorting, right? Yeah. So, and in this case, it's easier to see the clear ordering because otherwise it may be a little bit tricky to do it that way because you're trying to go from one to another. And the way that we're going to sort, of course, it's going to be by length. Uh, and here we don't have to worry about so basically the two things, right? One is, if you can only insert characters, obviously if you have fewer characters, it belongs near the front, right? So that's basically one of the core idea. Because and then it leads us to the second one, which is that tiebreakers, right? Well, usually that's one thing that I always worry about when it comes to sorting and stuff like this. But here we don't have to worry about tiebreaking because if two words have the same length, they don't, you can't, they're not in the same chain, right? So that's basically the idea. And once you sort it, you know that going from small to larger characters should be good enough. Okay. And then now, in theory, the way that you do it is just look at it all the way from j to I, and then best of I is equal to best. Sorry, if good of I and j, we probably have to rename this or something like that. Maybe if is processor, then this is equal to max of what it already is. I of j plus 1. And maybe I could even do, because this is the expensive, or this is the expensive function, right? I mean, it's not that expensive, it's, length of 16, but I am worried a little bit on Python performance, so this is the expensive function. So the way that I want to do it is gated by something like this, right? And this is a small gate, basically saying that if this doesn't create a longer chain, we don't even have to check whether it's processor. So that's basically the idea. And also in this case, then we don't need the max, because we know that if this is good, then we set it to that, right? It's a very small optimization. And at the very end, we do max or best, and that should be good. The base case is at 1 because each word is its own chain, the beginning of a chain of length 1, right? So that's why I have here. So that's like 80% done. The other one is processor, so we just have to write it. We might have to, we might have to figure out something for this, because calling functions 8 million times may be a little bit slow. But I mean, at least on Leetcode, just to be clear, in real life you definitely want this, but on Leetcode sometimes optimization. So we'll see if that's fast enough. But yeah, let's see. How do we check in a fast way? I'm trying to think whether it can be done in a fast way. Oh, I guess J is after J. Is J after I? And I guess we can just do. I was thinking too fancy, to be honest, but really you just do a 2-pointer thing, right? 1 point on I, 1 point on J, and keep moving, and you allow one mistake on J, right? So you allow to skip one thing on J. So yeah, and then here we go. I don't know. Index I is equal to 0. Index J is equal to 0. Oh, we can also do a quick check of actually, right? Like there are a couple of things we can have here. We can have an if statement that does like if length of words of J is equal to length of words of I plus 1. I was thinking that maybe I can put this here instead, to be honest. Some of this is the function cost as well, so I'm going to do it this way. And of course, I'm right. So let's put it there. And this is a very Leetcode specific optimization. I would actually recommend putting this up here and then just return false or something like that, right? But I'm trying to save some function calls. Maybe this is unnecessary. I don't know. We'll see how that goes, right? So then now is while. Let's see. I want to write this, but then it's going to call it every time on the while loop. So I'm trying to think. Actually, I guess we can just do this is equal to this. So then this only gets called once. And here the precondition is that J already has at most one thing. I'm doing a lot of optimizations here that I'm trying to articulate exactly what I'm doing. Hopefully it's helpful because I yeah, like it may be easy to kind of have what we had before was this, right? And it's very easy to kind of convert this into this, but without the logic, right? And people talk about why code is cleaner, etc., right? And the reason, or I don't know if this is cleaner per se, but the reason why I did it this way is because this len function is called only once, right? So that's basically the reason why. It's a very small thing, might not matter, but I want to explain my thought process with these like weird-ish things. But yeah, okay. So then now, if words of I of I is not equal to words of J of ij, oops, skip increment by 1. right? And then we always increment this by 1. Oh, wait. In this case, we skip and then we do ij does 1 and then we check the next one, I guess. This is a little bit confusing. This is a little bit confusing just because it is confusing. That's mostly why, but I have to check something here now. If skip is equal to 0, then you do this stuff. Otherwise, oops. This is actually like really kind of not sloppy, but there are some optimizations here. That's why I did it this way, but it is messier than I appreciated. I think if I had the while loop, this looks a little bit a lot more clear. I'm trying to work around the auto increment of II instead of, because in the other case, if we have a while loop, then we just don't increment II, and then we only increment II in the other case. But anyway, let's see if this works real quick. Oh, snap! Huh. Huh. Well, that means that this is never true, I suppose. Does this even happen? Wait, let me check real quick. There are a lot of things that could go wrong, I suppose. So we don't even call this. Did I add this one wrong? Word sub I, word sub j, that's okay. Plus 1 is greater than. This should be okay. So why do we not even call this once? Dun dun dun. Oh, I'm an idiot. I mixed up I and j. That's why. Because I did I and then j is the one to the left. So this should be. Actually, I think it's easier if I just do j for j and I. Because of the way that I had it. And I is the smaller one here. So yeah, I is the smallest one here. Smaller one here. I think this is right. Now I'm confused about my i's and j's. Hopefully this is more correct. It is not. I mean, it is more correct, but it's not sufficiently correct. Okay, so j is the one in the back, I is the one to the left, and the smaller one. Smaller. Oh, whoops. Wait. Yeah, oh, whoops. Yeah, j is the one we update. Okay. Hopefully this is more correct. Cool. Let's give it a submit. Some minor confusion, but hopefully this is fast enough. Wow, much slower than last time. But yeah, what is the complexity here, right? Well, this is going to be n squared just for these two loops, and then this one is the expensive thing that is O of alpha, where alpha is the size of that. Or not. Sorry. L, let's say O of L, where L is the length of the max length of the word. So this is going to be O of n squared times L plus n log n if you want to do the sorting here. But obviously this gets dominated, so we remove it. Maybe n log n times L or something like that. I don't know how length is done. But yeah, in terms of space, this is just going to be O of n, where n is this thing. Maybe you could also say linear because of words we sort as well. But yeah, that's pretty much what I have for this one. Let me know what you think. Let me see what I did last time though, because I'm curious why I'm so much faster. Huh. Oh, wow. Past Larry is smarter. I mean, different idea, but the same. Okay. I do want is sufficiently different enough that I do want to go over it a little bit. Okay, this one, wow. I guess I did do this thing way intense last time. So I do want to explain this one. I do have the video here, so you can go over it. So check that out if you really want a detailed one. But the idea here is that we only do 16 lookups, and this is actually way cooler, if you ask me, because the complexity here is that basically you go for each word, for each bigger word, same idea here, but instead of going for each I just to check, we go, okay. And I guess for n is equal to 1,000, it gets, this is more expensive, where for smaller n's, this is more expensive, right? So basically what happens here is this is saying, okay, let's say we have a word A, B, C, D, E, right? It tries to find, okay, this code is basically saying, in this kind of cool way that I didn't really think about today anyway. So it's basically saying, let's say we have a word that we're looking at now, this is the J loop here that hasn't changed, but let's say that, so what it tries to do is see if, does this exist? See if this exists in the previously, oops. Does this exist? Does this exist? And so forth, right? So basically it's going, okay, we delete the first character, see if that word exists. If it exists, then we do the lookup. Same idea that we had. And then see if the second character exists, etc., etc. I think technically, I mean, I lied a little bit about the complexity, because even though this part is O of L, this part is also O of L. So this is L squared. L squared for 16, what's that, like 2? I guess that is faster. Less than 1,000, so it is a bit faster. Okay, cool. Good job, past Larry. Slightly less good job, current Larry. So yeah, what's what I click on? That looks confusing. Okay, anyway, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join my Discord. Stay good, stay healthy, to good mental health. I'll see you later and take care. Bye bye from Aruba. Hopefully not for the last time, but for the last time this trip. So see ya.